So very good morning, students. Welcome to IIT NEET Foundation, our Focus C program by Krishnavedi Talent Schools and the Mastermind Schools. So once again, I welcome all the participant branches for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 9th. Today we are starting a new chapter, chapter number 7, fluid pressure, and we are in the session number 1. After completing the test 6 syllabus gravitation, today we are entering into the test 7 syllabus fluid pressure. Right? So there are two terms are there. We have discussed two terms separately. Then we have to combine them to understand exactly what is the fluid pressure. Generally, you know, when you are jump into the swimming pool, right? When you jump into the swimming pool, how the water will exert pressure on you. When the waves comes against you, it pushes to opposite direction. To overcome that, we need to apply some force. Similarly, when the wind is coming against you, it will push you back. That is the pressure exerted by the air. So from both of these example, right? Water exert pressure, air exert pressure. Right? And both water and air together called fluid. Why you are calling fluid? Suppose when you take one solid, when you place solid at one place, it won't flow. But whereas liquid and gases will flow. Will flow. When you drop some water on the floor, it won't stay there only, it will flow. When you draw air also, it will flow from one place to another place. So the two states of matter which flow, so far two, later maybe comes, which flow are called fluids. A matter which flow are called fluids. Whether it's a liquid or solid gases, they exert some pressure. The pressure exerted by the fluids are called fluid pressure. Take a balloon filled with water and make some holes. You see how much forcefully water comes out. That is because of the pressure exerted by the liquid on the walls of the balloon. So in this chapter, we are going to discuss about the how much pressure the exerted by the fluids, and with that effect, what is the applications in our day-to-day life, how this fluid pressure is applicable for us, where we can use in our day-to-day life. So many laws are proposed on this, like Bernoulli's principle, Archimedes principle. So many things are discovered because of this pressure. Okay, all these we'll discuss in the coming sessions, 4 to 5 sessions, right? But before that, let us see what are the topics we are going to cover. The first one is we should know first about the thrust and pressure. Then what is pressure in fluids? What is atmospheric pressure? What is Pascal's law? What is Buyon's force? What is Archimedes principle? What is density and relative density? And what is flotation, floating of the bodies? Why some bodies will flow? Why some bodies will shrink? Floating and shrinking. Reason for that. All these are the important concepts, important synopsis, which we are going to learn in the coming 5 to 6 sessions. Right? Clear? So these all are the key concepts what we are going to learn. Now, we'll start with the introduction. What we are going to learn today? What is thrust and what is pressure? Thrust and pressure. So, a matter mainly exists in 3 physical states: solid, liquid, and gases. Solids have definite shape and size, while liquids and gases do not have definite shape, which you are learning from your childhood. But Liquid and gas have common property of flowing. Flowing means moving. Hence, they are termed as fluids. The states of matter which flow are called fluids. Examples, liquids and gases. The interaction of fluids involved in the exertion of pressure, transmission of pressure, etc., which is studied under fluid pressure. So this interaction part gives clear about the what is fluid pressure. Fluid is the state of matter which flow. As solids does not have regular shape, geometrical shape, they won't flow. But whenever liquids and gases, they flow. That's why they both together called fluids. So the pressure exerted by these fluids is called fluid pressure. Right? Hope you are clear about the chapter name. Fluid pressure. You know what is the pressure? Force by area. The pressure exerted by liquid or gas is known as fluid pressure. That is our chapter conclusion. Right? Then, now come to the first term before knowing about the fluid pressure. Thrust. Thrust is defined as force acting by a body on normal to its surface. Any force acting on a body into the normal to the surface is called thrust. Thrust is nothing but force only. But acting perpendicularly, normally, is called thrust. The unit of thrust is same as the unit of force, right? That is dyne in CGS system, Newton in MKSI system. Thrust is also expressed in gravitational units called kg weight, because force can be gravitational force also. Kg weight or gram weight. So 1 gram force is equal to 980 dynes. Some relation. Then pressure. Thrust by area or force by area is called pressure. So what is pressure? Force per unit area. Force by area is called pressure, or thrust by area is called pressure. Okay, force by area. So, pressure is nothing but force by area or thrust by area. We know force is measured in Newton, Newton by meter square, or dyne by centimeter square, are also measured in Pascal. Pascal also a standard unit of, name of the scientist again, standard unit of pressure. Okay, so that we can convert force into mass into acceleration. So many ways you can convert that, and you can get the value. That we'll discuss whenever required. So thrust is nothing but a force acting perpendicular on a body, normal or perpendicular to surface, is called thrust. Thrust per unit area is called pressure. Thrust is measured in dyne or Newton, whereas pressure is measured in Newton per meter square or dyne per centimeter square or Pascal. So many other units are there for the pressure also. Okay. Then, so unit of pressure is given here, Pascal, PA, known as Pascal, which is measured in. Okay. Now, that is about only simple explanation for the synopsis. One is what is thrust, what is pressure, what is the fluid pressure. First we learn. As there are 3 states of matter, out of 3, solids are having regular geometric shape, so they does not flow, whereas liquids and gases will flow, which are together called as fluids. The pressure exerted by liquid and gases are called fluid pressure. So if the pressure, the force acts perpendicular to the surface, they are called thrust. The thrust acting per unit area is called pressure. So thrust is measured in Newton or dyne, pressure is measured in Pascal. This is totally about the first synopsis, a simple explanation. So before going for the second synopsis, where we discuss about the density and relative density, let me show you one video on the video on same, right? Just a minute. Just watch the video, then we can decide we'll go for the next one. Some idea about the fluid pressure.
Module. You will learn about pressure in fluids. Like in solids, thrust and pressure are equally applicable to the other states of matter, liquids and gases. As liquids and gases have the property of flowing, they are collectively referred to as fluids. Any material that has the property of flowing is a fluid. Like solids, fluids also have weight, and this weight exerts a force on the walls and the base of a container. We can demonstrate the effect of pressure in liquids through a simple example using a plastic bottle. Fill the plastic bottle completely with water. Then, make a small hole in the lower half of the wall of the bottle. You will see that the water gushes out through the hole with considerable velocity. This velocity is due to the pressure of the fluid at that point.
See how the water is coming. There is
now let's learn about the other forces found in fluids. Initially, let's see what the term buoyancy means. When a body is immersed completely or partially in a fluid, it experiences an upward force. The upward force exerted by a fluid on any object when the object is immersed in that fluid is called upthrust. The buoyant force, or simply buoyancy.
Buoyancy, that is called buoyancy.
The concept of buoyancy explains why certain objects float on water while others sink. All objects experience buoyant force when immersed in water. Floating and sinking of objects in water depends on how the density of the object compares with the density of water. An experiment will help us illustrate this concept.
Just a brief idea about the
First,
fluid
we
pressure.
take a beaker filled with water. Find two identical coins, one of iron and the other of plastic. Place both the coins on the surface of the water. The density of water is 1000 kg per cubic meter. The density of iron is 7000 kg per cubic meter. The density of plastic is 800 kg per cubic meter. The plastic coin floats and the metal coin sinks. So, how can we determine whether the buoyant force on an object will exceed its weight? The magnitude of this buoyant force depends on the density of the fluid. Therefore, the floating and sinking of objects in water depends on how the density of the object compares with the density of water. The plastic coin floats in water because the density of the plastic coin is less than the density of water.
So density is a very important. That's why before
Therefore,
knowing about density, we should know this.
The upthrust of water on the plastic coin is greater than the net weight of the coin. On the other hand, the iron coin sinks because the density of the iron is higher than the density of water. Therefore, The upthrust of water on the metal coin is not able to overcome the net weight of the coin. Thus, according to the principle of buoyancy, objects with density less than that of a given liquid float when placed in that liquid. Objects with density greater than a given liquid sink when placed in that liquid. As we saw, the density of iron is greater than that of water. But our ships are built of iron and steel parts, and they don't seem to have any problems staying afloat in water. To better understand why a ship floats,
See,
let's
when
look
it
at
is
a
so
very
heavy,
simple everyday
while it is
example
floating.
of buoyancy. Take an empty plastic bottle and close its cap airtight. Put the bottle in a bucket filled with water. Then, try to immerse the bottle in water.
to float.
You'll observe that attempts to push the bottle down in the bucket are unsuccessful, and the bottle floats on water, even though the density of glass is higher than that of water. Here's the reason why. The bottle contains air inside it. The volume of the bottle includes the volume of air in it. The density of air is much less than that of water. This means that the overall density of the bottle becomes lower than that of water. Hence, the upthrust on the bottle is greater than the weight of the bottle. Due to this, the empty airtight bottle is pushed upward when we try to immerse it completely in water. Therefore, the glass bottle floats on water. In order to make the bottle immerse completely in water, the volume of water equivalent to that of the bottle must be displaced. To keep the bottle completely immersed, the upward force on the bottle due to water must be balanced. This can be achieved by an externally applied force acting downwards. This force must at least be equal to the difference between the upward force and the weight of the bottle. The reason for flotation of the ship is similar to that of the flotation of the glass bottle. Even though the density of iron is more than that of water, the ship does not sink. The total volume of the ship includes the volume of the air in the ship and the volume of the metal used in making of the ship. This reduces the overall density of the ship to a value much less than the density of water. Hence,
So, clearly explain about what is exactly the effect of pressure of the fluid. So, before knowing about this second synopsis, I want to let you know about what is the. So, first what we learn about what is the fluid pressure, what is fluid. Fluid is nothing but a state of matter which flow. As we know, so far we have 3 states of matter. Of course, 4, 5 also there, but only 3 are there for time being. Solids, liquids, and gases. As we know, solid is having a perfect geometrical shape. When you place any place, it won't flow. But whereas other 2 states, liquid and gases, will flow. So, liquid and gases together are called fluids. The pressure exerted by these fluids are called fluid pressure. What we call fluid pressure. So, before going for the pressure, should know what is the word thrust. Thrust is nothing but force only. the force exerted perpendicularly to the surface of the body. Suppose when you are applied to open the door. So when you want to open the door, you apply the force perpendicularly. That is called thrust. Right? So thrust is measured in either in Newton or Dyne because it is a force only. Whereas pressure is nothing but thrust per area or force per area, which is measured in Pascal. Okay. That is the what we learned till now. Now we enter to the second synopsis here. Synopsis 2 explains about the what is density. Just now we have seen in that. What is density? What is relative density? It's also called specific gravity. So fluid, again explained, fluid includes liquid and any gases. They begins to flow when sharing the stress applied. The fluid have no definite shape. They assume the shape of the container of the vessel, which we are already learning from our lower classes. Common. When you come to the part of density, what is density? Mass by volume. The mass per unit volume is defined as density. That is, density is equal to mass by volume. Right? So, density is the product of fluid represented by mass into volume, mass by volume, M by V, where M is the mass and V is the volume of the body. So when you come for the units, mass we know measured in kg. Mass is measured in kg. Volume is nothing but meter cube. Length into breadth into height, or gram per centimeter cube or cubic centimeter. That's what they given here. Okay. SI units. Some rearrangement is done here. Suppose when there are two bodies are there of different mass and different densities, we can write the volumes here. V1 plus V2, how much you can get. So V is equal to mass by density. Volume is equal to mass by density from formula. Right? So when there are two volumes are there, different volumes are mixed liquids. They are written as V1 plus V2 is equal to M1 plus D1 or rho. Generally, it is represented rho. So like this one, right? When different volumes are combined. So density is nothing but the ratio of mass by volume, which is measured in either kg per meter cube or gram per centimeter cube. Okay. So like that, there are so many combinations are given here to know about the what is arithmetic mean and harmonic mean, which is comes in your mathematics progression topic. Right? Now there is a specific weight is given here. Next part is what is specific weight or weight of weight density. So same only, weight by volume. In place of mass, you know, mass is different from weight. Weight is due to gravitational pull, whereas mass is the quantity of matter. In case of specific weight, you can write weight by volume. Specific weight is given by weight by volume. Density is given by mass by volume. Right? So then relative density, very important, because a specific weight is pure water is at 4 degrees is 9.8, because at 4 degrees special property is there for the water. So relative density is nothing but density of the liquid by density of water at 4 degrees Celsius. Relative density, comparing density of one liquid with another. So we know, as we know, the density of pure water is constant at 4 degrees. With respect to that, we can measure the density of any liquid by using relative density, which is also called as specific gravity. Right? There are few terminologies when you are knowing about when you are learning about the pressure. So density, specific gravity, specific density. Right? So you go more details in the coming classes about these comparisons. That is a second part of the second synopsis, 1 and 2. One synopsis contains only 3 definitions. 2 contains mainly about the density and relative density or specific gravity. So relative density have no units because it's a ratio. Density of substance to the density of water, or density of liquid to the density of water. We can find out the real density by many methods. Okay, there is a specific gravity bottle will be there, from which you can find out the density of one liquid or relative density of solid. You can find out. So relative density is a very important concept of finding out the density of any liquid with respect to density of water at 4 degrees Celsius. Okay. So in next class, we'll discuss more about that, and also about the pressure, about pressure and fluids, how the fluids will exert pressure, what are the type of fluid pressures, downward pressure, upward pressure, sideward pressure. So many pressures you can see in our day-to-day life. So explanation of all these things followed by the many laws. The many laws explains about the pressure of the fluids. Pascal's law, Archimedes principle, Bernoulli's principle. Now all these things come across, and there are so many applications also in our day-to-day life. See here. These pictures show how much pressure the liquid exerts. So first picture shows clearly whenever we are placing the holes, the liquid come with a great pressure. The second one is how much pressure acts on a solid dropped in a liquid. How many angles, how many ways the pressure exerts on a solid to make it into shrink or make it into float. Okay. So that's all for today. More we'll discuss in the next class. We have no hurry. So define fluid and give examples. So fluid is nothing but a state of matter which flows. That is both liquid and gases, collectively called as fluids. Examples you can give any solid, any liquids and any gases. Right? So that's all for today. Thank you, students. Have a wonderful day. Thank you.